blood pressure and what things affect it. We're also going to trace a couple special circulations in the body. One of those circulations is going to be the hepatic portal circulation. That's a circulation that brings, there's a system of veins that brings all blood back from the digestive tract and sends it to the liver. We're going to talk about why that's so important. We're going to also trace what the fetal circulatory system looks like. So when a fetus is growing, what's different about a fetus's heart and lungs than an adult's heart and lungs?
Smaller.
They're much smaller?
It's not developed.
What part isn't developed? The heart or the lungs?
The lungs.
The lungs, right? So that baby is not oxygenating its own blood. Right? That's what we do with our lungs. We oxygenate our blood. So where is that baby receiving its oxygenated blood from? From the mother, right through that placenta. And so we're going to talk about how the baby's circulatory system is different because of that fact. And there's some holes. You know when people are born with holes in their heart, or like they catch them later on in life? That's because when you're a fetus, you naturally and purposely have holes in your heart. And then they close up 30 days after birth in order to form your normal adult heart. You do have a hole in your heart whenever you're a baby. So that's why you get one sometimes later. It never closes. Has anybody had a son or daughter, or you specifically had a hole? Did they tell you you had a hole in your heart? No, I generally have one person in class who either has the hole or knew somebody. Okay, so let's look at arteries and veins and capillaries more specifically today. The definition of an artery, guys, is carrying blood away from the heart. 90% of the time, arteries are what? Oxygenated or deoxygenated? They're oxygenated 90% of the time. What's the exception to that rule in the heart? The pulmonary arteries. The pulmonary arteries are deoxygenated because they haven't been sent. That blood hasn't gotten to the lungs yet, right? So there is no oxygen possible inside those arteries. And then the arteries that come back from the heart, back from the lungs to the heart, what are those called? The pulmonary veins, right? What's weird about them? They are actually oxygenated. They are the oxygenated veins in the body. So we always have a couple exceptions to the rule. But in general, arteries are oxygenated, veins are deoxygenated. You have to rely on the definition of the artery. Arteries carry blood away from the heart. Veins always carry blood back towards the heart. And that's how they're named. If the vessel's carrying blood to the heart, it's called a vein, no matter if it's oxygenated or not. Does that make sense? Mm-hmm. Cool. And that's, I remember even the first couple years I was teaching this, I would still point at the pulmonary arteries and call them pulmonary veins because I saw the blue. So you're really going to have to hammer that into your head. You're going to want to call them pulmonary veins. Okay. So capillaries. What important event happens at capillaries? Capillaries are the thinnest blood vessels in the body. They're the terminal blood vessels in the body. What's different about the capillaries' function than the artery and veins function? Arteries and veins just transport blood. That's their entire purpose, is just simply transporting blood around the body. All blood ends up at a capillary. What happens at that capillary?
Filtered. Is
What?
it filtered?
Go ahead.
Is it filtered?
Almost. Some things are filtered, but let's talk about oxygenation. Let's talk about blood gases.
The exchange occurs there.
There's an exchange of oxygen for, what's the byproduct that all your cells make? What do we exhale? CO2, right? There's always an exchange of oxygen for CO2 at a capillary bed. And that happens because the capillaries are so thin. So we have gas exchange at the capillary bed. And if we were to draw that gas exchange, get my red, my blue. I lost my red. That's all right. Orange will work. So we have an artery here, and picture orange as red, okay? This is oxygenated, high in O2. That artery gets smaller and forms a capillary bed. These are little tiny capillaries, okay? This is the entire size of that capillary. Just this little line, that's the thickness of it. And then we have the venous end of those capillaries. This is where the gas exchange happens, when the vessels become really, really, really thin. So here, what gas is delivered to the cells? Here are all the cells in the body surrounding the capillaries. There's a capillary bed for every single cell in your body. So what's being delivered to that cell? What gas? Oxygen, right? And what gas is being expelled and picked up by the bloodstream? CO2, correct. So the oxygen leaves the capillary bed. The CO2 then enters the capillary bed. So if we look at venous blood, it has a high amount of CO2 and a low amount of oxygen, right? Because it was all delivered. And if you look at the artery, the arterial end, it had a high amount of oxygen and a low amount of CO2. So this is gas exchange, guys, and gas exchange is always 1-to-1. Oxygen for CO2. Got the H. Gas exchange is always 1-to-1 oxygen for CO2 every time. So we have 1-to-1. And these are cells out in the body. So these are part of the systemic circuit. What's the definition of the systemic circuit versus the pulmonary circuit? Pulmonary circuit are all the blood vessels in the lungs. The systemic circuit, all the blood vessels in the body, right? The purpose of the lungs is what, again? Why are we breathing? See, here's the thing. Yeah, that's what you want to say, but really, when you get down to it, why are you breathing? Cellularly, why do you breathe? It's just simply to put oxygen inside the bloodstream. All you're doing when you're breathing, the only reason you do it is to put oxygen, force oxygen into the bloodstream so it can be delivered to these cells. If a cell doesn't get oxygen, what happens to it? Done for, right? And that's what a heart attack is. It's when the heart doesn't get its oxygen and dies. So we will really rely on this oxygen to survive. How is gas exchange different in the lungs than it is in the body? This is the gas exchange in the body, right? This is delivery of that oxygen to cells. How would this be different than gas exchange in the lungs? And I'll start you guys off here. We have the pulmonary artery that's deoxygenated, right? Sending that blood to the lungs. And then this is a lung capillary bed here. What's different here than here? Oh, it's still a 1-to-1 exchange. How is this different?
CO2 is on this side and oxygen on this side.
Right. CO2 is being sent out of the body, right? Because we exhale CO2. That's if you measure exhaled air, it's got a high amount of CO2. And what's entering the bloodstream then? O2, right? So it's the same exchange 1-to-1, but it's just simply flipped. In this scenario, in the lung capillary, CO2 is leaving, oxygen is entering. In a tissue capillary, anywhere in the systemic circuit, oxygen is leaving and CO2 is entering. And then that CO2 comes back to the lungs and gets expired. Does that make sense? Mm-hmm. So we have the same thing going on, right? But it's just flip-flopped in the lungs than it is in the vessels. Any questions so far? Okay. So, let's go ahead and look at the structure of a normal blood vessel here. The arteries are thicker than the veins. The veins appear very, very thin. And when you look at them, they're just a little bit more bluish. The arteries look a little bit more pale reddish. There are 3 layers to both arteries and veins. They are the tunica. They're all given the name tunica. That just means layer. We have the tunica intima. We have a tunica media. Media referring to middle. And then we have a tunica externa referring to the outer layer. Same thing in veins, guys. We have a tunica intima, we have a media, and we have an externa. But the differences are in the sizes of those layers. So we see all 3 layers here. This is an artery. What do you notice, just your gut knee-jerk reaction, how is an artery different from a vein? Just by looking at that picture. It's just much thicker. And the vein is very, very thin, right? The vein's got some extra stuff. There's a valve in the vein. There are valves in veins. Why are arteries thicker? What's the reason arteries are thicker?
So I can keep that.
They're not carrying more blood, but you're on the right track. They're not carrying more blood. Both vessels carry the same amount of blood to and from the heart.
Is it to keep
But
the
what-
oxygen in?
Both vessels can actually keep oxygen in. Oxygen can only leave at the capillary bed. Think about arteries. Are arteries closer? Which one is closer to the heart, vein or the artery? The arteries, right? So when the heart beats, that artery better have a thick wall to withstand that pressure. So it's simply just a pressure thing. There's a much higher pressure in the arteries. There's 100, what's the normal blood pressure? Ish. Anywhere 120 over 80 or so is normal, 120 over 70. 120 pressure units in the artery, right, at the highest pressure. That's what you're measuring here. You're measuring what the pressure is inside this vessel. Because that's, what artery are you measuring blood pressure on? What is that? Brachial artery. You don't measure blood pressure in veins because there is no blood pressure in veins. That sounds really weird, but there's very little to no blood pressure in veins. So they didn't develop a thick layer because they didn't need one. So there's a major difference, guys, is the tunica media is almost not visible in veins. It is there. It's about 1 layer thick, whereas in arteries, that tunica media is very, very, very thick. It's the thickest layer of an artery, of the 3 layers. The tunica intima, you're seeing here on the inside, there's also a difference there between the 2. It's in both vessels, but in terms of the veins, the tunica intima forms valves that are located in in strategic places on veins, especially in veins in the leg. Why would you need valves? And you can relate this to the heart itself.
To make sure blood don't flow the wrong way.
Yeah, if you're a vein in the leg, okay, picture yourself as a vein in the leg. I don't know how you're going to do that, but the valves are projecting into the center of that vein, right? If blood is traveling upwards this way, and there's hardly any pressure to push that blood upwards, it's going to want to go back down. But we have the valves to catch it and prevent it from going back down. These are just like, there are no strings that attach these valves, okay? So what valves are these analogous to in the heart? Which ones? Remember, some of the valves in the heart had those heart strings, and then some were just on their own. The semilunar ones had no heart strings, right? The tricuspid and bicuspid, they had the strings that attached them to the ventricles. But the semilunar valves just had 3 cusps that acted like, remember how we said they're like upside down umbrellas that hold blood? It's like an upside down umbrella catches rain, right? It's just like that upside down umbrella would catch blood.